What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines. We are going to be talking about quadratic functions here in Unit 4, and specifically today focusing on a couple different ways to solve quadratic equations. So solving quadratic equations is something that you started back in Algebra 1, and we're going to expand on that a little bit. We're going to start to bring in some imaginary numbers and some factoring techniques that we learned in the last unit to build on what you learned here in Algebra 1. So let's start from the basics, and let's define a quadratic equation. So a quadratic equation is any equation in the form ax squared plus bx plus c equal to 0, where a, b, c are all real numbers and a is anything other than 0. So it's going to be some real number, 1, 2, 3, maybe 1/2, but it can't be 0. So we have to have that x squared factor. This is something we talked about in the last unit. Now, we are going to work on solving these, finding solutions to these equations. So notice that I expanded on the standard form ax squared plus bx plus c, and went ahead and set that equal to 0. So that's how we're going to find solutions, which we're also going to talk about being x-intercepts or zeros to a quadratic equation. In order to do this, one of the methods that we're going to use is factoring, which we worked on in the last target. And factoring relies on one key concept that you may already know, but something we're going to put a name to. This is what we call the zero product property. So if we have any expressions that are real numbers or real valued expressions, let's call them a and b, and a times b is going to be equal to 0, then that means either a is equal to 0 or b is equal to 0, or both things, a and b, are equal to 0. And so this is what we use when we have factors. Let's take a and b and assume they're factors of a quadratic equation. This is what we use in order to solve the quadratic equations. If we have the factors, and those factors have to be equal to 0, then we can solve for the value of x using what we know about linear equations. So let's jump right into some examples here. In problem number 1, it says solve each of the following by factoring. So I made a quick change there. I wanted to make sure my examples matched yours in the notes. But in problem number 1 says solve each of the following by factoring. So what we want to do is, in order to find solutions to a quadratic equation, we need to put it in standard form. Ax squared plus bx plus c equals 0. So what we need to do is we need to get this equation set equal to 0. So you may look at this in problem 1a and see that there's a 5x over here on the left side, and we need to move that 5x, so we're going to subtract it. So if I subtract that 5x from both sides, this is going to leave me 3x squared minus 5x equals 0. Now, this gives me an expression that I can factor on the left-hand side of the equation. So when factoring, the first thing that we want to do is we want to take a look and see if there's a GCF. And here in 1a, there is a GCF. That GCF we might see between those two terms is x. So I'm going to factor out an x. So what that's going to leave me with is x times 3x minus 5, and that's equal to 0. Now, according to the zero product property, this means that my two factors, out of these, either one is equal to 0, both are equal to 0, or the other is equal to 0. So what I can do then to solve this is to set my factors equal to 0. So when x equals 0, I'm going to have a solution to my equation. Also, when 3x minus 5 equals 0, I'm going to have a solution to my equation. So in this instance, 3x minus 5 equals 0, I'm going to need to solve this for x. So I'm going to add 5 to both sides, which would leave me with 3x equal to 5. Then I'm going to divide 3 by both sides, which would leave me with x equal to 5 divided by 3, or 5/3. And now I can go over to my calculator and check this. So I can go back to the original equation, and I can type in 3 times 0 squared, and that's going to equal 0. And then 5 times 0, and that's going to equal 0. So 0, when I put 0 in for x here in this equation on both sides, that's going to make both sides equal one another, and then my solution is okay. I can also go back and try this with 3/5. So let me put in 3 times Let me go ahead and put this into parentheses. So 3 times 5/3, sorry, rather I said 3/5 earlier, I meant 5/3, squared. And this equals 25 over 3. Now let me try the other side of the equation. 5 times 5/3. And that is also going to equal 25 over 3. And so we can see that 5/3 is a solution. So I can check these by substituting them back in. So I used the factoring method that we learned previously with the greatest common factor, the GCF, to factor this into two separate expressions that I can then set equal to 0 and solve if needed. In 1b, I'm going to need to do the same thing here, similar thing. I'm going to start by rewriting my equation. So I'm going to list 2x squared first. Then I'm going to have minus 5x. Then I need that 3 from the other side of the equation to move over. So to get that over, I'm going to subtract 3 from both sides. So I'm going to have 2x squared minus 5x, reordering those now, minus 3 equal to 0. Now I want to factor this expression. Well, there's no GCF, so I'm going to go ahead and try to factor this down into two sets of parentheses. The first term in each has to multiply together to give me 2x squared, so that's got to be 2x and x. The second term in each has to multiply together to give me a negative 3, then through distribution add to give me a negative 5x. So I'm going to go ahead and go with positive 1 here and negative 3. Let's check that. So when I distribute the inners, that's x. When I distribute the outers, that's negative 6x. Negative 6x plus x does give me negative 5x. So I have factored this one correctly. So 2x minus 1, sorry, 2x plus 1, and x minus 3. These are my factors. So now through the zero product property, I can set these both equal to 0. So 2x plus 1 equals 0, and x minus 3 equals 0. I'm going to solve these independently. So for 2x plus 1 equals 0, I want to subtract 1 from both sides. So that would give me 2x equals negative 1. And then divide by 2, x equals negative 1/2, or negative 0.5. Then on the other side, my other factor, x minus 3 equals 0. I'm going to add 3 to both sides. So that's going to give me x equals 3. So there I have two solutions for this quadratic equation based on factoring and the zero product property setting them equal to 0. Take a look at another example. Example C. Again, I want this equation to equal 0 for when I start. So I've got 4x squared over here on the left. I'm going to subtract a 12x to move that over to the left. I'm going to add 9 to move that over to the left. And now that's going to leave me with 0 on the right. I need to factor this expression. So there is no GCF. Again, it's a quadratic trinomial like the last one. I'm going to try to factor that down into two binomials. Now, I need to find factors where the first are going to multiply to 4x squared. The last ones are going to multiply to a positive 9. And then through distribution, the inners and the outers are going to add to give me a negative 12. So let me try a 2x and 2x. 2x times 2x is 4x squared, so that's going to work for the first term. I need a negative and a negative because I know I have to multiply to give me a positive 9, but through distribution add to give me a negative 12. So both of these need to be negative. I'm going to go ahead and try the factors of 9, 3, and 3. So this gives me negative 6x. The inners, the outers give me negative 6x, and those do add together to give me negative 12x. So these are the same factors. They're identical, but they multiply together to give me 0. So 2x minus 3 times 2x minus 3 is 0. So I can set now my factors equal to 0. In this instance, I'm just going to go ahead and set the one factor equal to 0 because the answer is going to be the same. So I would add 3 to both sides, get 2x equal to 3, divide by 2, so x equals 3/2. So my solution then, I have a singular solution. It's going to occur twice. It's going to occur 2 times, but my solution is going to be 3/2. And again, we could go back to the calculator and check this. So I'm going to go ahead and check this. 4 times 3/2, squared gives me 9. And then 12 times 3 halves minus 9 on the right side of the equation gives me 9. So 3 halves would leave this equation balanced. So after factoring, you can set the factors equal to 0, and that's going to allow you to solve a linear equation that's going to give you a solution. If you're getting this process, go ahead and pause the video and see if you can complete problem D. Let's go ahead and take a look at problem D. So in problem D, this is already set equal to 0, so my first step here is going to be to go ahead and factor. This is the difference of two squares. So remember, the difference of two squares is going to factor into the conjugate of the square root of the first term and the square root of the second term. So x is being squared to give me x squared. 5 is being squared to give me 25. So this is going to factor into the conjugates of x and 5. Now I can set both of those factors equal to 0. So x minus 5 equals 0, and x plus 5 equals 0. So now I can add 5 for this expression on the left to get x equals 5. And then I could subtract 5 for the expression on the right to get x equals negative 5. So my answer here for x would be plus or minus 5. So this is how we can use factoring to solve quadratic equations. You can start by factoring the expression when it's set equal to 0. And then because of the zero product property, set each one of those factors equal to 0 and solve them independently. This is our first technique. The second technique that we're going to use is the square root property of equality. The square root property of equality essentially is following a process that we used earlier in the year, a reverse order of operations, or what we called SADMEP, to solve quadratic equations. What it relies on is having a single variable for x. So being quadratic and having an x squared, which you can see some done in some of these examples, but not having an x to the first power. So it relies on this property. So if I have a as any algebraic expression and a squared is equal to k, then if I want to get rid of this squared, essentially what I'm going to do here is I'm going to basically take the square root of both sides. Now the result of this is going to be a plus or minus option. Now the reason for that being, let's say I'm trying to solve the idea, let's write this expression. Let's say x squared is equal to 4. So basically what I'm trying to find is a number that I can put in for x that when I square it is going to equal 4. So if I check in the calculator, we should all realize pretty quickly that, hey, if I put in 2 and I square 2, 2 squared is 4. So this works. But also, if I put in negative 2 squared is also 4. So my solution for x would need to be plus or minus 2. So this property is going to help us to solve when we have to find a value for x when there's no need or no way for us to factor in this instance. Again, we're following the reverse order of operations. So you remember PEMDAS, and we can go backwards here, SADMEP. So the first thing that we want to do is make this equation, or get the variable on this equation by itself. So we want to eventually, if I take a look at 2a, it says solve each of the following using the square root property of equality, or reverse order of operations SADMEP here. I want to work at getting the x squared in 2a by itself. So the first thing I'm going to do is subtract this 3 from both sides. So that's going to give me negative 4x squared equals negative 6 minus 3, which would be negative 9. Now I'm going to divide by negative 4 on both sides. And now that gives me x squared equals a negative divided by a negative would be a positive. And I'm going to leave this as a fraction 9 over 4. The reason I want to leave this as a fraction is if you put it into a decimal, it's going to be difficult for us to take the square root of decimals. We don't know how to square root 225. But if I want to get rid of this exponent, this square, I'm going to do the inverse operation. I'm going to square root. Remember from that property of the square root property of equality, I'm looking for both positive and negative instances here. So when I square root x squared, x is going to be by itself. When I square root 9 over 4, essentially I can look at this as what's the square root of 9 and what's the square root of 4? So we have talked about this earlier in the year. The square root of 9 would be 3, and the square root of 4 would be 2. So my answer here is going to be plus or minus 3 halves. I can check that in the calculator by taking negative 4 times, let's say, 3 halves, square it, and add 3, and that answer is negative 6. I could do the same thing here, but inserting a negative 3 halves, and that answer would also be negative 6. And so we see here that plus or minus 3 halves is our solution. So essentially, again, we're following the reverse order of operations to get the x value by itself, or the x squared by itself, then using the square root to remove that square, that power, getting the x by itself and having a solution. So let's go ahead and take a look here at B. I have my x squared over here on the right side of the equation. So I'm going to leave it there, and I'm going to move everything else to the other side. So I'm going to subtract 6 first. So 20 minus 6 would be 14, which is equal to 1/2 x squared. Now I want to get rid of this 1/2, so to get rid of the 1/2, I would multiply by 2. They would cancel each other out, so I need to multiply both sides by 2. So 28 is equal to x squared. Now I want to get rid of my x squared, so I'm going to take the plus or minus the square root of both sides. And so that would be plus or minus the square root of 28 equal to x. So the square root undoes the squared operation. Now, if I wanted to give this answer in my calculator, the square root of 28 is going to come out as a decimal. We're not going to round this, but we're going to give the best possible answer simplified. So what I want to do is see, using my calculator if I need to for help, find factors that go into 28 that I can square root. So I might come down here and see that, okay, 4 times 7 is 28. So I could rewrite this square root as the square root of 4 times the square root of 7. And the square root of 4 can be factored into 2. So plus or minus 2 square roots of 7 would be my answer here for x. So again, I'm following the reverse order of operations to get x by itself, then taking the square root of both sides, to get x squared by itself, then taking the square root of both sides to get x by itself, and now I have my solution. Let's look at one more problem, and let's go ahead and do this one together. Now, what you may do is you may look at this problem and think that you can simplify it, and you could. You could multiply out this square. You could distribute and multiply x minus 2 times x minus 2, and then afterwards distribute the negative 4, then combine your like terms to write a new equation. That would work, but that's going to be a little bit more work than what we need to if we follow the reverse order of operations, or SADMAP here. So the first thing I'm going to do to try to get x by itself is I want to add or subtract. So I'm going to subtract 36 from both sides. So now I get negative 4 times the quantity x minus 2 squared equal to negative 36. The next thing in the reverse order of operations would be divide or multiply. So in this case, I'm going to divide by negative 4. If I divide by negative 4, I have in parentheses x minus 2, and that quantity is still squared, equal to 9. Now I want to get the x by itself, but there's that negative 2 inside the parentheses. I can't work with that negative 2 yet because it comes in parentheses, which is last. So before parentheses, I need to deal with exponents, which means I need to take the square root of both sides to get rid of this square. So x minus 2 is going to equal to positive and negative versions of the square root of 9. So this is both positive and negative versions of the square root of 9. So how I can do this by hand is I can split this up. So x minus 2 is equal to the positive version of square root of 9, and square root of 9 is 3, so x minus 2 equals positive 3, and x minus 2 equals the negative version of the square root of 9, so negative 3. Now I can make one small step to get x by itself. I can add 2 to both sides. So x equals 5. and x equals -1. And there I have my two solutions, 5 and -1. Let's go ahead and let's double check to make sure these are solutions. So my calculator, I'm going to take -4 times one x value, let's say 5, minus 2, quantity squared, plus 36. And we'll see that that does equal 0, so 5 would be a good solution. I can do the same thing, but instead put in a -1. And again, I would get a 0, and so these are both solutions for my equation. So these are our first two ways to solve quadratic equations. We can solve by using factoring in the zero product property, or we can solve following a reverse order of operations in the square root property of equality. This looks like a good place to stop for today. These are the first two of many methods we're going to have. As we come back in this second part video for QF1 notes, we'll explore some other methods. As always, thank you guys for tuning in, and I'll see you soon.